Angel, Mark, Jacob. You're the only two that are here.
I guess so.
Okay. Now, I want to get to the curriculum. I forget where things are. Sure, I got this on. All right. We're on module 4. And I'm going to talk sort of overview on the stuff. It's a physical layer and it's talking about cables. It doesn't really go very deep into it right here. I'm going to talk a little bit more than what they've got right there. And Thursday, I didn't realize we had cables this week. So I didn't bring today. But Thursday, I will bring with me my whole set of sample different type cables for y'all to look at. So as I'm talking today, I'm going to talk off of this one little piece of wire right here. And I'm going to talk about it further than just this wire. And then Thursday, you can really see what I'm talking about. Okay, got all on that. So we're going to go from there. So let's say it doesn't go a whole lot depth into talking about the cables in this chapter, and that's really what it talks about in this module. It's just an introduction, real brief overview of these different type cables. It's going to come back later, I know, in more depth. I'm not sure where or how they're going to do on that. I assume when we get into the Ethernet, that's not where I saw it earlier this morning, but I know there's some more talk on this whole part. So they're talking about the different types of media in here, because we're talking physical layer. Okay? So they're mentioning some of the devices to you on it, but that's very briefly mentioned. But they just show you real quickly on it about the devices that you're running, however the signal's coming out. The signal goes out, as I mentioned last week, I think it was, that you're really sending the signal out on the media in 3 different types of media. Copper is going to be one of them. Fiber optic or light is going to be the second one. And then the third one is the air or your wireless. Okay? The wireless is using air, fiber optic is using light, and copper is using the copper. So that when you get into the last 2, you're really only, this doesn't have as much breakdown to it really as the copper does. They spend the time there on talking about 3 different types of copper. So we'll talk first in terms of copper, and then if we get to the wireless, I'll talk briefly on it, but we'll talk slightly on the fiber optic. Okay. And I've got examples to show you of the copper stuff and of the fiber optic. Okay. So I say I'll have those Thursday. Actually, I'll have them with me tomorrow when I go to do the online session. I only meet with them for 1 hour, once a week. So with the copper, you are sending an electrical signal across the copper, as I understand the data across the copper. As a result of it being copper, it is going to have a couple of things that can present problems to it, which the main ones, as they mentioned to you, is the EMI and the RFI. Okay? The electromagnetic interference and the radio frequency interference. There is some other things could get in there too. We're going to talk about, and so that's forms of interference. We're also, I want to mention to you a brief little bit on crosstalk, which is going to be an issue purely when we're looking at twisted pair mainly on that one. That crosstalk's not going to be an issue where we talk about coax and when we get into the fiber optic or the wireless. So if we're looking at the wire, the copper, the oldest one out there of the copper essentially is the coaxial, which is where stuff used to be on. The twisted pair has been around for a long time too, and it may predate on that, but as far as computer communications, you really had a lot of coax in the past, and then you moved into where twisted pair for it today. So those have changed slightly. With the coax, which I don't have a piece with me today, so you've got to go off of just what picture they give you and my description of it, and if you have seen coaxial cable, which you may have touched on. Okay. Coax is going to be used by cable TV systems, is what they traditionally use. You're still seeing coax with them from the pole to the box in your house. Okay. Different coax than it used to be when it was just TV. But within organizations, your networks used to all be running, a large number of them at least, used to be running using coax cable connecting machines altogether. They switched off to twisted pair years ago, and some of it was twisted pair while stuff was still coax in some cases. So that coax has pretty much disappeared out of LANs, the local area networks. Although I'm going to mention to you a thing or two off that which Will doesn't mention, but just for information for you. And I will show you some things on that. So that coax was there, and now instead of using coax, that you're using twisted pair. The place that you're still using coax essentially is pole to box in the house for cable connections. Although in some cases you're still running cable down, coax downstream. Okay, but in a lot of cases, and rapidly changing on that is that the cable companies are converting everything out there on the street to fiber and ceasing to use coax. What they used originally for their coax was not compatible for data. They worked on different amperage on it. And so that stuff was all replaced back in the early 2000s generally, though it might not be in some cases to some houses. But most of the time they've gotten that replaced out with a better quality coaxial period. Yeah, if you find a house that somebody has not used cable for their internet, they may still be running the old coax across the line. But most likely fiber to the pole. Okay. So that has changed in time. And that you're obviously also still in a large number of cases running coax from the box to the TV. Although to your computer and stuff, you're running wireless system, will be more towards that now for your home installations, or you're running wire. Okay? And running twisted pair to do that for the wire. All right. With the coax, it had a single piece of wire that ran down the middle of the cable. Then it had wrapped around it a piece of plastic. And then it had wrapped around that piece of plastic a piece of either braided or solid foil. And that's about the thickness of it. It was like aluminum foil. Okay, it could be some slightly thicker, but it was right in that type of thickness of it. Fully flexible, etc., and not very thick. And then a piece of plastic around that, which is a black, a lot of times black plastic on the outside, but the outside could be any color. Inside plastic was generally a piece of white plastic. Okay? That cable down the middle carried your signal. The wrapping was your ground neutral on it. And that's how it worked on it. And then the plugs just had the one wire sticking out of the plug, which you slid into the female plug and you passed it down somehow. And generally it fastened down onto the plug. Sometimes it's just all with a turn of it and then attached in. Sometimes it's screwed on. Okay? Everybody follow on that part? What was used in lands originally, and again, you're not going to find coax in lands anymore. I don't know of any place that's using coax for a land. Speed limitations is the big thing, okay? That it did not speed up over time. But when you had coaxial cable that was thinner and flexible, pretty flexible, and not much bigger than the twisted pair cable. A little bit bigger than what basically is what runs into your house or wherever you've seen somebody that's got coax going into their house. That is a thin little cable, bigger than the twisted pair, but not much bigger, and flexible, pretty much like it. That had a 2 value always associated with it, which I believe was 200 megahertz, but I'm not going to hold you on that one, but it's not your materials. Okay? The 2 is the important part. Remember that. That is what went to the individual machines. Okay? There was also a thicker one that was probably about that big around. Okay? That you would run as a backbone, generally down the halls or wherever where everything else attached back into. That one had a 5 number associated with it. The thinner one, you would actually cut it into and put connectors on it and then put a T connector in if you want to run the wire on. The thicker one was a lot harder to try to cut it like that, first off. And what they actually had on it was they had vampire caps for that one. So that you had a cable right there that had a wire running down the middle. Okay? With the Vampire tap, what you did was you put a piece of the tap on each side of the cable, and the wire going off to wherever it went to the PC or whatever, wandered on off there. But this had on it a sharp little V point that went down in it. Y'all follow on that? These then screwed together, and what ultimately happened was, as you screwed them together, that point dug down into that cable and made contact with that metal. Okay? That was a Vampire tap. And if you look at it and think about a vampire, it looks like a vampire on it. Okay? Don't work like a vampire. And that's what it was called. Most likely, you'll never see the term out there today, other than that being trivia type knowledge, or it might be something useful sometime for some interview of just dropping out there. Regrettably, and I really don't remember ever seeing one of these, okay? And I don't have one of those. Nobody's ever given me one, and I really didn't work with that 5 cable anywhere. That when I started was towards the end of its term, and that I wasn't doing any cabling or anything anywhere that they probably had that. Okay. So I just didn't deal with that. It wasn't until after a few years in it that I started doing stuff. If I could ever get a Vampire tap, I'd love to have one to put my demo stuff. And my demo stuff has been either things people have brought to me and said, I thought you'd like to have this, or somebody asked me, would you like to have such and such? We've got such and such way in it working, I can bring you. Go, yeah. Or things that where I worked at and stuff that I held on to something. So, but that was how that one worked. Now, as far as this cable, so this was the one that had the 5 on it. This one had the 2s on it. Okay. This one, you just put a T connector in it. If you want to connect another wire into it, these just plugged together. But there was another piece went in here that had a wire from off. And so it just plugged a T into there to plug between the 2. So that this little piece in the middle here is plugged into here, and then let the wire plug in. Okay. I will show you one of those Thursday, since I do have that. Okay. The other one was on when you were using cable. You actually had to put a piece in, and it's out of my mind right now exactly what it's called. It was a delimiter, but you had to put a piece on the end of the cable that marked the end of the cable on both ends. So you couldn't have, you could have all these connectors coming off and everything, but cables couldn't just lay there open-ended, like they do with twisted pair. You have lots of places, you got plugs laying around that have nothing in them, etc. You couldn't do that on twisted pair, on coax. Okay? It had to have ends on it. Okay? That way, what that did was that stopped the signal from just bouncing out there forever. Okay? It would absorb signals off of it. And so you had those to do on that. Okay? You think about like where the cable runs into your house. Well, it's got something on the end of the coax cable. There's not an open-ended cable just waiting. Okay? It goes into something, and that's the end of it. So it's got a terminator. It was a terminator. And so it just terminated the ends of the cable. And what you had was just a plug on the end. Then you plug this piece in. So I say, I'll bring, that's in my bag of stuff. All right. So that was coax. coax is disappearing. There's not much. The only places I really know coax being used is just in that limited space there now on cable. Okay. And that's rapidly starting to come to an end. And then in some cases, like I say, it could still be running down the street in some places, but they are in the process of replacing the coax cable on the streets to fiber. Okay. And fiber is a whole lot faster and carry a whole lot more stuff on. So that's their big part on that one. But you do need to be aware of coax because it is still used some. It's just not used much. So we follow on that one. Twisted pair has got a lot of use out there. We've got people saying, and had people saying for a number of years, that twisted pair is going to go away and disappear. I would question that one probably at some point long in the future, but I think it's going to be a long time before we ever see twisted pair disappear. Twisted pair has continued making improvements on speed, etc. There's a lot that you can't do fiber everywhere, and the expense of fiber is ridiculous. We're trying to do it to the desktop. You can run fiber to the desktop if you want, but it's going to cost you a fortune. So typically, you're either running twisted pair to the desktop, or whatever your device is on, or you're running wireless. Now, obviously, you're doing more wireless on that, but the advantage of twisted pair is a little bit more secure than wireless. Wireless is very insecure. There's also plenty of locations where wireless will not work, interference, etc. Also for security concerns. And you can fence your building off in wireless so that we could put a metallic shield around the building and that a wireless inside the building wouldn't leave the building, basically. But now fiber is going to be the most secure of the three. Because it's sending it through as a light wave, and you can't just eavesdrop on it. You can't eavesdrop on this. You've got to be close to it. Wireless, it's got to be somewhere in range. You can pick up everything on wireless. Okay. Which makes it a very insecure. So this is going to hit the middle of the ground, but it's a little bit more. Okay. So, twisted pair has been around a long time. And with what you're going to work with twisted pair today, is going to be where I've got money. This should be probably, it's Cat 5 for sure, and I suspect it's Cat 5e. Let's see if it's here. Cat 5e. Twisted pair cable is split into basically 7 categories, I guess now. There is an 8th and a 9th in development, but not really standardized and finished out on it. 7 might be. I haven't seen 7 used anywhere or seen 7 stuff for sale yet. I do see it in the cabling magazine every month about articles about what they're doing with 7 and 8 or 7 and 8. 6 categories is really what you're worried about. Okay? So there's 1 through 6. And you're really not worried about all of them. One, forget it. You already have to worry about that. That's still obsolete. I can't remember what the standard was for that, but it's been long gone. Been obsolete for over 20 years. Okay? And I can't remember what it is exactly how it developed. 2 and 4 are also obsolete. And you probably won't encounter 2 and 4, but I will show you a piece of 4, I believe it is, on Thursday. But you don't see that used anymore either. 2 and 4 were for token ring networks, which was an IBM product. Very popular in the 80s and early 90s. And then Twisted Pair took over the market. Okay? Although Twisted Pair was out there then too. Okay? Actually, UTP took over the market. 2 and 4 are Twisted Pair also, but they're thicker wires. Seems like there's only 4 wires in there. But I could be wrong. We're going to talk about topologies later, and we'll talk about the ring network. And that's what token ring used. You will still find token ring on fiber optic, but you really won't find it on copper. You'll find FDI out there, FDI, that uses token ring on fiber. Token ring had a nice advantage, and still does, is it's 100% dependent. But with what we're doing with Twisted Pair now, we're getting that also in Twisted Pair. But historically, token ring, every packet that was sent, you knew it was received, you got confirmation back. And basically, it was token because for a machine to send, it had to have the token. The network would pass this token around the network, pass it to each machine. You got something to send. If you didn't, it went on to the next machine. Something to send, if you did, it sends it. It gets replied back to the machine that sent it to was received. So you will find token ring on fiber, which is used to be, still in some hospital environments because it was absolutely assured the signal was received where it was sent. And if you think about it, if you were in ICU with heart problems or whatever other type of problems, if suddenly you flatline or something goes crazy wrong, you want the nursing station to know immediately and absolutely know that things have changed on your medical condition, right? Because typically they're not going to have a nurse standing over you watching the monitor the whole time. Because the nurse is down the hall or across the room or watching the monitors there at the station, not watching at your place. So it's got to get to them. Okay? But as soon as something goes wrong, you want their attention. Them. Okay? With this, the traditional way on it, packets would get lost. And we'll talk about that later, of course, with CSMA, CA, and CD. So you'll learn what they stand for. And so not everything ever gets there. Stuff gets lost, and that's built in. It doesn't show up, and it's asked for consent again, etc. Well, in some cases, like medical, you don't want that. And that's primarily where it's still got some uses. So then 3 and 5 and 6 are all similar. 3 was the original regular UTV cable standard. 1 may have touched on it, but say it's so much the whole. We'll see that. 3 allowed for 10 megahertz per second speed on your communication. Okay, so 10 was speed. If you go to buy a router or whatever, or a network card today or something, or buy a computer, you're able to see speed set on says it operates at is 10/100/1000. Okay? You really don't run around 10 anymore, but they still make stuff cross compatible. Okay? Token ring with that Cat 2 and Cat 4, Cat 2 ran at 4 megahertz. Cat 4 ran at 16. But that 4 and that 16 were not really comparable to the Ethernet 10/100/1000. Okay? Because it was an absolute guaranteed deliveries, and so it had a lower number there, but the effective throughput 16 really gave you more close to what was 100. Okay? Probably gave you the equivalent to 50 or 60 somewhere. So it wasn't as drastic as 2 different things. You were looking at 2 different ways of measuring. Okay? So, Cat 3 ran at 10. You will still see Cat 3 cable out there today, but not much. Cat 3 cable today is used. A moment there, I left cars going around the circle on the wrong side. They're not. I'm not getting confused. That's the smallest little circle right now. When a tractor trailer comes in, it's going to have to fit something. Especially whenever they put whatever they're going to put in their one. You notice that's raised curving on it, which you don't normally do on a circle wheel. The may be raised is going to slope instead of a sharp regular curve. So that if something does need to go up on it, it's not going to shred your tires. I wasn't quite built like it should have been built. Cat 3, a lot of times they will say in terms of using for telephone cable. Telephone cable has only 3 pairs on it, where the data cable has 4 pairs. Okay. Telephone cable uses a smaller plug that only has 6 pins in it, versus a bigger plug for data cable, which has 8 pins in it. That's an RJ11 for the smaller one, RJ45 for the bigger one. Remember those 2. I don't think they're mentioned here in this chapter, but they're going to come back to you later, of course. Okay. And somewhere around mid-semester, we're going to go through on how to close. Okay. There used to be along the range of where this was taught, but like I say, there's going to be some more detail taught later about types of cables and stuff. So that should be in the Ethernet chapter, really should be, which is about chapter module 7, 8, somewhere closer to the one. So you'll see Cat 3 used sometimes for telephone cabling because it works fine for it, and that none of them having cable made just for them. It's 3 pairs. And get Cat 3, it's 4 pairs. You don't use one of the pairs, and it works fine. Okay. However, today, most people would recommend to you if you were wiring a building for a telephone and data, wire all with the same cable. That way, if they quit using the landline, the cable you've already got in there will work fine for adding another connection to their computer network or for the IP telephone. I don't know over here, particularly in the new building or even in this building for that matter. I know we're using IP telephone in both places. I'm not sure how they have done it here. I know over at Walker, it was originally with telephone cable through the building for the telephones and data cable for the computers. And then when we went to IP telephones, the telephone cable was just laying all there, all wired through the school with no usage for it. And that the phone, that the data cable plugs into the phone, and then there's data cable from the phone to the computers. It would be better if we had a data cable to each of them to have better throughput on it. You still get good throughput, but you would even have better if you had each on its own separate port on the switch. Which, if twice have been wired with data cable for both, that would be real simple. Just change the plugs in there, change the plug in the wall there from the RJ11 to RJ45. And we're very quick, relatively quick and simple. So, Cat 5 is what you're going to see extensively used today. It has been for over 20 years. I can probably safely say that with that. Somewhere 20, 25 years, but I definitely tell you back 20, 23 years ago. And then along there's when it came on. Cat 5, and Cat 5 has been improved with what they call Cat 5e, which is actually the distance. Cat 5 would actually look exactly the same to you, except for the number of twists that are in the pair per inch, and each of the pairs actually wraps around each other at intervals. And on Cat 5e, it does it more often than on Cat 5. Okay? Those twists, in both cases, will reduce your crosstalk, which was the other interferences that we had. What crosstalk is where one of the pairs picks up stuff coming across the other pair. And that there's signal coming out because it's an electrical signal going through these wires. Just like when we go up to any other electrical wire here or whatever, if you get close to it, you can pick up that there's electricity comes off of that wire. Okay? You can move certain devices close to certain wires that have more voltage in them. There's interference coming off on it, okay? Which gets back to your EMI actually. But in this case, it's data fusing with other data. And that then messes with the data. Okay? The twist in it cut that down. Okay, it's basically you've got the colored wires usually got actually carrying the data. The white wire, and there's a white one for each color. So that's the white one here. That's a white orange. There's a white blue, and a solid blue here, and so on. Brown. So the white one of the color carries the negative charge to it. So you have the two parts just like on regular electricity. And those are twisted together to counter effect each other and balance themselves out and reduce the amount they give off. And it cuts the cost on. And so with that, with Cat 5, it's got more twists than Cat 3 did. But it's still the same cable. Okay, so if you look at the wires, you look at the outer sheet, it's the same thing. Well, it's the twist that makes the difference. Okay? Then, and 5E got more enhanced because 5 was really designed for 100. Okay? And I've said megahertz all day, and it should be megabits per second. Okay? I've been wrong on that one. I just didn't sound right. It's megabits per second. And so 100 is what this was designed for. 5E actually will work with 1,000 megabits per second. Bits, not bytes. And so 5E is working with that. There was sort of an enhancement to make it where below 5 will generally carry 1,000 also. That's just, you really don't want to stretch it to the limits. Your limit on the length from device to device, or piece of Cat5 cable, of your twisted pair cable actually, is 100 meters. So about 300 feet, really, 315 or something. You play soccer, just like in the soccer field, if you play on regulation soccer. Okay? Regulation soccer field is 100 meters long. If you're a football, American football player, it's a little longer than the length of football. Okay? Now, like in here, what it measures from is not, because you've got a wire going from here to the wall that hooks in the wall. And then you got the wire running from there down the hall to wherever the circuit goes. That they've got communications room with the switches and circuit devices like we've got sitting over there on that over there. Goes to a wall there, and this cable goes from the wall to the switch. That whole 100 meters counts everything from the switch to the PC. Now, if you start thinking about it, you can use up 300 feet pretty quick. We're not talking about 300 feet as a crow flies, but 300 feet as it takes us to run that wire. So first off, you got to run the wire from here to the wall. Okay. Then we're going to run the wire up into the ceiling at some point. So probably going to run it along there distance, then run it into the ceiling. Got it? It's running suspiciously light in the corners. There's 2 corners. Got it? Not sure how it gets across from this side of the ring to that side. It's, you know, because I see all of them plugged in the floor over there, but I don't know where they're. And they're obviously plugging in that trough along the wall here. And there's what goes up here. Okay? So you can imagine the distance involved in that. But it's that whole, and then when it gets to the other end, it's got to be the same stuff. So think about it, you're going to lose 15 feet going up to get up to the ceiling, to go down the hall. You may have to go around the stuff. Odds are these all to the hallway, and then go down the hall from there. So your machine's got to go over to there, down to there, up, over to the hall, and then down the hall where it's going. 300 feet is not that far. Okay? And you really don't want to run it at max distance. That is, under optimal conditions, signal will carry that far. The signal will deteriorate as it goes over time, over distance. So, and if interference, etc., gets in the way, it will deteriorate faster. So, if it's any longer than that, or even less distance than that, you really wouldn't want to run that for. Use general. You're going to have some device there to regenerate the signal. Does everybody follow on that? It's sort of like look at the headlights on your car tonight. When it gets dark, they only shine out so far, and then at a certain point, they keep getting dimmer as they go out, but they're good out to a certain point, then they dim off pretty fast from that point on. Don't do much on it. That's that point where it suddenly starts dimming rapidly on you. It's effectively like 100 meters on. Does that make sense, sir? It's the same, exactly the same. As it travels that distance, it gets weaker. Okay. So, they're going to send the information across all those cables, those wires, and that will carry it through. Okay. That's 5. 6 is what's really designed for 1,000, and now they're coming out with 40,000, and it's supposed to be 100,000, but 40 is really where they play a lot. It's a lot of money. Numbers changed on it. So that 6 is more designed in terms of that, 7 is designed to make it go even better. But you're still going to have the same limitations on it. But with 6, the cable physically changed. It's still 4 pairs, just like I got right there. However, in the middle of it, it's now got a plastic trough, and I will show you a piece of it on Thursday. 2 pieces of it. And it's got a trough all the way through this whole cable. That separates the 4 pairs out into their own little sectional trough. They still twist around as they go, but they're staying separated out with plastic separated. That stops the crosstalk up on it and speeds it up. However, it means it's not as flexible as this. Second thing is you don't want to, even on this cable, we don't want to run it somewhere like that. Trying to get signal around that sharp bend, it's going to be a little harder on it. Number 2, you're looking towards breaking the wire down in there also. Okay, because these are all little wires. Okay, those thin little wires, so they will break easily. You bend them a few times, they will break. The Cat 6, you can't do quite as sharp of turns because it just physically won't let you bend it that much. Okay? It's got that plastic trough. So 6 is going to cost you more than 5, and that's what we did for 5. You can still be popular enough. You can go to Lowe's or Home Depot and buy a box of little wings of Cat 5 cable. And sometimes you can find 6 there too, but not much. Okay? Everybody follow on that? And then we'll learn how to put quotes on these and how to make straight through cables, crossover cables, and rollover cables, console cables. Later on. Right. Any questions on that? Now the other part is you want to be careful where you run the cables also. In this case, in this room, the fluorescent lights are not right up in the ceiling. So you've got more flexibility to run the cable here. But you do not want to run the cable across fluorescent light beams because those ballasts give off a good bit of EMI. Okay? And so you'll get all kinds of interference. You also don't want to run the cable around microwaves. And that hits a problem sometimes to people, particularly places where they got a kitchen or a break area or whatever. You want to sort of try to avoid the spot where the microwaves. And other motorized stuff. It means in plant areas, sometimes you've got this work to get around interference, EMI, and RFI coming off of motors and stuff out there. RFI is radio frequency interference, which is more of what comes off radio stations, but electric motors can produce RFI besides producing EMI. Okay. So you got a variety on those. Questions on the twisted pair?
For fiber optic, would that change the distance?
Yes. Fiber optics is a whole different myth. And coax, something I think I just now remember my numbers on. The smaller wires you could run 200 meters, that's what that was. And the big cable you could run a 500 meter distance because it's such a big cable. Now, y'all got that basic idea of this. And they just go very basics in the curriculum. If you look at the curriculum already. Fiber optic, they say very basic also, but I'm going to be a little bit more of a give you a lot of detail. First off, fiber optic. It is a little glass tube, which could be plastic. Runs in the middle, that's a tube, and it is thin. Typically, the size of the opening inside that tube is the size of a hair response. Okay? Y'all have all seen fiber optic, the fiber of that little tube, because you can go and find in stores for sale that you can get fiber optic lamps that have all kinds of little pieces of plastic tubes out that displays the light on the end of the tube where the bulb is sitting down here. And you've got it out here, a little light showing on the end of the tubes. That's exactly the same thing. Okay? Those are all plastic tubes. That one, but on the other, could be glass, could be plastic. Glass is going to generally work a little bit better for you, but there's a lot of plastic done on it now too, high quality plastic. Corning is the major maker of that glass tubing and plastic tubing. They've spun off the cookware stuff, but that's where the company started from, was the cookware stuff, making cookware stuff that you could use in your oven or on the stove, whatever type thing on it, everything else on it, glass. So they were glass experts. So making tubing with perfect glass line inside of it fit in their business. And that's where they're making their money now. Okay? So now it's two companies. After a few years ago or something back, they spun them off separately. Which you see in a lot of cases. That tube is in there. It has around it in there that there is a protective layer on it. Okay? It could be plastic, but if it's decent fiber optic cable, it will be Kevlar. What do we use Kevlar for? Bulletproof vest. It works great. Bulletproof vest, the idea is, where Kevlar works on is, it will stretch slightly, but not much. It doesn't give much. And so it blocks the bullet from going through. Because if he gets shot wearing a Kevlar vest, he's going to get a bruise off the skin. It's going to stretch a little, and he's going to get hit by it, but the bullet's not going to come on through on him. So he's going to know about it for the next week or two. But he did get hit. But that's all he's going to know. Okay? He's not going to be having to worry about the hole and coat down and everything else. On the tubing, you want the Kevlar on it, that they use Kevlar all around on it. And you'll see sometimes on tests that they won't always use the word Kevlar, but they will use the generic term for Kevlar, which is Armit. I think it's what it is, if I remember right. Either of y'all remember or know what Kevlar's generic name is. ARMID or something like that. Okay? That's the generic term. Kevlar belongs to a company. Okay? So if you're going to say it's Kevlar, it's got to be made by a company. And there's other people that make Kevlar type stuff. It's wrapped in that to keep it from stretching, because it doesn't stretch much. Because that's how Kevlar works. It's tight, it doesn't fit. Okay? So when you've got Kevlar hanging in a building, or not Kevlar, but the fiber optic hanging in a building, or sometimes you've got Kevlar running on poles down the street. Typically, it's buried in the ground, but not always. You ever noticed? I don't know if you ever noticed, but telephone cable, and now most of it's fiber. that when they get to where there's a creek, they don't dig a hole under the creek and lay the cable on under there. They run it up on a pole across and back down the pole on the other side if you want to break. It's not you're driving down the road. It's sort of like, okay. So it's to keep it from stretching, because when it's cold out there like right now, cable, if you'll look at the electric lines and stuff around, they're much straighter this time of the year. When summer gets here again, and it's 95 degrees outside, if you'll watch, electrical lines hang a whole lot lower than they do in January. It's 30 degrees outside, because they stretch the heat. Well, the Kevlars keep that from happening, because if that piece of fiber optic cable stretched like that, guess what would happen to that glass tube in the middle? It would break, and now it doesn't work, because it's got to be a solid, non-broken bond. Okay? So it's going to typically be wrapped in a Kevlar type foam. Okay? And then it's going to have a plastic shield around that. Oh, the one thing I forgot on this was, we talked about unshielded twisted pair, which is what this is and what you're normally doing. There is also shielded twisted pair, which is SCP. And what it's got is, around these pairs here, there's a piece of metal that wraps all the way through here, just like we mentioned in coax. And it works as a ground and a shield around it to stop these signals from getting out and other signals getting in, so it reduces that interference that way. Does that make sense? Forgot that. So with the fiber optic, it's like that. Depending on what type of fiber optic cable you got, it could be that it can run somewhere around 1,000 meters. So it can run several miles of distance without needing a repeater. Okay. And when we look at it later, we'll see those numbers. Speeds are a whole lot faster. So you'll be able to send stuff through on fiber a whole lot faster than you can on copper. The connection from this building to the other building should be fiber optic. Whereas inside the building, well, both buildings should be all copper. Okay. When I wired Swainsboro Tech back in '93, that had been contracted to do it for us, and I still didn't do it. I've done it one time, shown how to do it with the FD connections. Actually, one or two of those type of paper in my kit. That's all I've ever done. It's more complicated than copper. I just haven't had anything to do. I set copper in the buildings there on that campus, and I had the fiber between the buildings, because you find all your traffic running across that, just like you're going down the street with cable or anything else, whoever you're running. Okay. Just that they're doing the same approach. And you may actually have some fiber inside the building to connect some switch rooms or whatever. Now, since that's brand new, this building, it would be just fiber from building to building. So we probably a fiber connection over there to the high school building. Because after all, we've been working together a good while to build up until we put up. Because even when college had that was we building working together. We took one person to career academy, put it there, but we still were doing a lot of commonality. And that I'm sure we've got connections running between on. I can't say that for down. I haven't seen it. That's the way it should be. You know, like at Walker, I know there's fiber running between those buildings. fiber running between the campuses. Not sure about this campus for sure, but I know we've got a fiber line that runs from Walker and home, and a fiber line that runs from Walker to Peterson. But they had a fiber line put in just for that both directions. Now, going to Rome, there should be several repeaters along the way. Going from Walker to Peterson. You know what they put in? It's possible they didn't put in. I suspect they did. But they put all those just as fail-safes. That reduce if something could have wrong, how far it is. All right. But that's with fiber. Now, fiber does run two ways. There's locations to it. Is that there is multi-mode and there's single mode. Single mode says we're sending one light signal through a piece of fiber. It travels down the center of that tube and never touches the walls. So that means when you get a curve to go around or go to something different using fiber, it can only turn at a maximum turning rate. Sort of like railroad tracks. So we look at railroad tracks for a train to make a 90-degree turn. It takes a long distance for the tracks to do the whole curve around on that where the car pulls up, makes it just turn. Okay? Fiber optic's going to be more like a train. You can't turn it instantly. Okay? So it runs in single mode. It runs on one single light down the middle of the phone. That's going to be faster. Okay. Multi-mode won't cost you twice as much, and allows you to send multiple signals across at the same time through the tube. It bounces signals off the side of the tube. So if this is our tube, remember this is way oversized drawing. If it was single mode, it just runs right straight down that middle. Everybody follow on that? If it's multi-mode, one signal will come in, and it goes along and it bounces at a certain angle. Another signal comes in. And goes through. That can travel on both at the same time. Another one can have another pattern on here that goes along, and you can have a number of signals traveling at the same time. Now, they're bouncing off the sides. Now, in both cases, you can't have any cracks in the side or anything, and distinctly, completely on the multi-mode. Because at all, the least little crack in there, that's going to drive that signal to just smattering out and destroy everything. Okay? With single mode, if there's a crack in the side, that's also members of our talking because it's going to capture reflection and stuff off that and changes what's being sent. Okay. So it can't have any cracks or imperfections to it. But that's with multi-mode right there. And so with multi-mode, it can send multiple signals at the same time, but because it's bouncing them off, one, they're traveling a further distance, and two, it can't travel them as fast as it can travel when it's sending them straight through. Now, there's still traveling speed of light. Okay? We're not running stuff at speed of light for the simple reason we don't have equipment that knows how to deal with that and the reading. Okay? So speeds on fiber are going to be a whole lot faster than on copper and on wireless. Because actually copper is going to be faster for you than wireless, although wireless is gaining up onto there, but you still, if you want a really good clean speed, copper is going to be better than wireless, fiber is going to be better than copper. Okay? Fiber is also going to be the most secure one. You can't eavesdrop on fiber. At least as far as we know. So we'll phrase that one slightly different. You can't put some device up there by that tube and see and be able to detect what the light is going through there. Pick up what that's from. Copper, you can get near it with an eavesdrop device. You can get what the signal is going through it. Regardless of eavesdrop yields, where you used to eavesdrop on telephone calls. They put devices near the telephone line and know exactly what's going across the telephone line. Well, you can do that with copper. Okay? Wireless, you don't even have to get near all the stuff. You just got to be in the range of it. Because we can go down to McDonald's, sit in the parking lot at McDonald's, and find out what everybody's sitting in there at McDonald's using their wireless. Or you can sit there and pick up your neighbor's wireless signal if they're not encrypted. If they're using WPA or WPA2, like they should be, then even though you picked it up, you didn't get anything because it was encrypted on that. Okay? But if they're just sitting it out hot, or they're sitting out using WPA, which hardly does anything on it, we don't know exactly what they sent. So, but fiber is going to be the most secure one. Now, the caveat I will throw you on that is the Russians claim that they have a way to be able to eavesdrop on fiber optic. And they claim they have a submarine out there that has been eavesdropping on the giant fiber optic cables we've got running under the ocean from North America, Europe, and everywhere else, all over the place. All of these fiber optic used to be metal cables. So the sensors, regular electrically, you could wire count those. But now you've got fiber optic where it's obviously they run a whole lot faster and everything works a whole lot faster. But the Russians claim that they can sit near it and pick up the signals. There's been no proof of that other than allegations put out by Russians and by people having fled Russia and stuff. Supposedly they are doing it. So far, everybody's comment from the rest of the world is nobody has any idea of how they can be doing it. It's, I suppose, some way possible on it. But I really doubt it. I'll just throw it out there. Go and read some computer publications and stuff. You will see regularly something else about some other allegation on it or whatever, and the Russian stuff sitting by the cables and stuff and supposedly giving us stuff. That was metallic cable, copper cable, yeah. Us and the Russians had some sitting all over the place under the ocean, picking up from those transatlantic, transpacific server cables to pick up signals from. But now with fiber optic running on it, theoretically, no. Is it possible that they've done it? Well, I guess there is a slight possibility there. But I'd be more inclined to think that it's a conspiracy theory developed by the Russians. Y'all heard enough of conspiracy theories about the Russians and other conspiracy theories. But to me, this sounds like it's a conspiracy theory of the Russians. Okay? Because if they can convince us that they can wiretap that stuff, essentially. Then that they're trying to convince us they're hearing things that they're not supposed to hear. And that changes obviously a little bit more, but obviously using a real good encryption software. Okay, unless they can figure out how to encrypt it. In most cases, if you're using the high-end encryptions, which is what for the things they're looking for, which is primarily military and CIA type secrets and stuff, that stuff should all be going across there like highly encrypted anyway. That states are going to say it's going to take hundreds of years with today's equipment to ever have a chance of breaking the encryption. And you know it's not going to take that long because we're building faster and faster machines, etc. And that means at some point in the future we'll have machines that can do it fast enough to do it real quickly. But by that point we'll have even stronger encryption methods. Okay? So that I would throw in as a caveat to you on that one. But basically, fiber is considered very secure. If you cut the line on that to then put a device in there, put ends on it, and plug it into a device where you can listen in, it's going to set off markers and bookends saying there's no signal across this. If you cut the copper and just stick in a plug on it, you can do that really quick. And where it's done, and because it loses some signal anyway, which fiber doesn't, it's not going to necessarily, if it's done correctly, necessarily stand out that you've done such like that. And obviously on wireless, we just stick the device right there, and that way you can just grab the device sitting there. Okay? So fiber is going to be the one that's going to cost you the most. Fiber is going to give you the fastest. Fiber is going to be the most secure. And most accounts is secure. But distinctly is the most secure. Copper is going to be the next most expensive. Copper is also going to be the next in terms of speed. Typically, although wireless is at this point in time getting up to copper speed, but copper is moving up on speeds again. It goes into that 40 gig. I haven't seen 40 gig wireless. Probably 250 is about as fast as I've seen for wireless out there. Maybe 400 separated it, but not a gig or over for wireless. Chattanooga for EPB and the other companies now too catching up with them. With fiber, that's where the 1G in, and now we're doing the 10G. And downtown Chattanooga is 10G speed. And 40 is probably coming soon. And then wireless is the least secure. Wireless has the advantage of you don't have to run any cable or anything, so it's cheap. So also means at certain locations, that's the one you need to use. If you put networking into a historical building, wireless is probably the way you need to go. Because running wires in there or fiber optic in there is going to destroy the looks of the building, well, the traditional look on it, or having holes in the walls, etc., that you don't want to do in a historical facility. You can do wireless. So wireless has got its flaws. Wireless doesn't limit us to working in one position. Because we love our phones for that, to be able to check things and text wherever we are. Our laptops connected in wirelessly, or even our desktops. My desktop at home is connected wireless. Although I have a wire sitting in my living room that will stretch all the way across my living room and through my study to my computer. So I can connect in wired to it or to another computer that I'm working on. Typically I use that just for connecting to another computer. So sometimes you can do wire that can't do wireless. And if I've got someone's computer fixed, wire is where I'd rather connect it initially. They can get their wireless working after that. Although sometimes I'll work on wirelessly, but sometimes it's going to be better with wire. But I am using wireless to my desktop. All right, questions on all those videos? I'm at 2:14 by the clock in the back of the room. I've got 45 seconds to answer questions. And actually, I'm starting to see Check State tonight and Kimball, Tennessee. And I'm not sure how long it's going to take me to get there. Nice part is I've got 4 hours to do it. So I'll get there in time. I'd like to be there in plenty of time to eat supper, so I'll figure out tonight how that works for me, how much time I'm going to stay there. As for Walker, I know I can make it there now. Then I'm going to add the 45 minutes or so over there, although I don't have to go all the way back up to Walker and go across. And it'll be faster for me. My GPS is going to try and tell me to go to 75 to 24. Kimball is over in South Pittsburgh, where all the stores and restaurants are. So before we go up over Mount Eagle, that's where I'm going to. But I take 136 and go across Lookout, go over there to Trent, and go catch 59. It's a straight shot out there across the short piece of 24. I don't want to touch 24 and check there. One, I don't want to go into the 2475 intersection because how much time is there, and then when I get downtown, it clogs all that part over there also. So when I was going from Walker last semester, I found that it's a whole lot faster for me to go 6 miles down the road. That I'd make it the same amount of time than 6 miles down the road, drive across the mountain on 136. And then catch the interstate up instead of going straight up the 4-lane to 24 and going over, and my nerves were a whole lot calmer. And it was just about the same amount of time. Before the GPS, my thinking it was a little bit faster. But I didn't get caught in all the truck traffic and downtown Chattanooga on 24. So I'm going to start doing that tonight going over there. Thursdays, how long? That's just one I know. Because the other confusing one on me is they're in Central Time Zone. It's just beyond Central Time Zone line. So the class starts at 5:30, that's 6:30 our time. So I got the advantage of that one. Actually, it all goes right this afternoon for me. I'll be last semester. Generally, I was usually got over there just before 4 o'clock, and I could go to the steakhouse over there and get the lunch special. But if I walked into the steakhouse before 4 o'clock, they'd sell me the lunch special, so I could get a cheaper, or a little bit smaller deal, but it's all I need anyway. As opposed to, so hopefully that'll work for me with this. If not, I'll get something after class. That's where the time does bug me. Because then I lose an hour coming back. So class gets out at 8:30 over there, which is really 9:30, and I get an hour drive back home. But the school up there at Chat State does pay me mileage based on me driving from their main campus up there above Chattanooga over to that campus. So they give me some money for my gas. So that makes it okay. All right, any other questions? Did that, has either of you looked at module 4 yet? Because that pretty much covers what's all in there. Actually, more than covers what's in there. But when I've looked at it twice today, that's what I see.
I think it was 4 yesterday.
But 4 is fiscal year and it looks at paper. And I did pull off the lecture this one. This morning, somehow, I turned off the phone. That's weird. Obviously, when I turned the recorder on, it must turn sound back on the phone. I was going earlier, but you know when the phone rang when you were in here?
Yeah.
Just as I was setting up. What? I thought it was on vibrate. I would have taken the call anyway. Whoa, it's supposed to be on vibrate. I set it on vibrate before I walked back in here. I just went and looked. I was going, I need to put this back on sound before I put it in the car with me. Which goes through much yes and there, so I'm okay on that. And it was sitting on sound again. This morning I turned on the recorder on here to record the lecture. And then after the class, I realized it when the cases were on 4, I forgot about it. And when I went to turn it off, it's already off. And it only recorded 18 seconds or something of the lecture. That's not a good race. I have not gotten them posted out there. I am going to go ahead and post them out there. One person in your class today, I think, actually did watch it. Was going to watch it live, I think. Because he said he wasn't going to be able to be here. But that he was going to watch on Collaborate. I don't know if he was doing live or recorded. And then I did put out there yesterday